So earlier we said that if the cell voltage is positive, that means it's spontaneous. And it also implies that if the cell voltage that we calculate is negative, it is non-spontaneous. And that is correct. And one way to identify that is to say, well, that just means the reaction goes backwards. But maybe we want the reaction not to go backwards, but we want it to go forwards. So for instance, let's say we want to take sodium chloride and convert it into sodium and chlorine. And that's a redox reaction because sodium in the ion form, right, is +1, chloride is -1, and elements have an oxidation state for each atom of 0. So we can see that the sodium has gone from +1 to 0 in oxidation state terms, and so that must mean that we have gained 2 electrons there. So it's been reduced. And what about the chlorine? So we've got chloride, and we've got 2 chlorides have changed into chlorine. And so to balance the charge, we need 2 electrons on the other side. And what have we got here? So the first reaction, right, is reduction. The second reaction is oxidation. So if we were doing these reactions in a cell, where would they occur? And the answer is, of course, ox, red. Remember red cat and ox, so reduction occurs at the cathode, so we'd have to make this the cathode part of the cell, and oxidation takes place at the anode. So we'd have to run this reaction at the anode. Now if we go ahead and we calculate the cell voltage, we can just look up these standard electrode potentials. They're always tabulated as reduction, so don't worry if we're only doing one reduction and one oxidation. We don't change anything. This sodium reaction here is -2.71 volts, so very, very unfavorable to go forwards, actually quite favorable to go backwards. So the other one is +1.36 volts. That means that the reduction reaction is quite favorable. And of course, the reduction reaction is the opposite of what we're doing. So we've got 2 very unfavorable things here. So it's not looking good. In fact, if we calculate E cell, and we take E cathode minus E anode, so that would be -2.71 volts, -1.36 volts. We can see that is not looking good. That is -4.07 volts. So in electrolysis, that means that we can actually make this reaction occur if we apply a voltage greater than that. So if we supply voltage, so that is we push electrons backwards with an energy bigger than or equal to, actually bigger than, otherwise it would be in equilibrium, bigger than 4.07 volts, we can drive this otherwise non-spontaneous reaction. And what is the reaction we're looking at? Well, if we sum those 2 equations together, right, we get the reaction above, which is 2 sodium ions and 2 chloride ions make 2 sodiums and a chlorine. So we can drive this reaction by supplying the electrons with at least 4.07 volts of kick, and then the electrons can be pushed in the direction that they really don't want to go. So that's electrolysis for you.